At Envision Virgin Racing, we are very much a data-driven business. If we don't have access to our data, the cars don't even leave the garage to go to the track. So it's very important for us to not only collect as much data as we can, but also be able to analyze it very quickly. This is where AI and machine learning plays a role. We realized that we cannot do all of this by ourselves, and working with Genpact has been amazing. Getting that different perspective and make sure that we can use Genpact's knowledge of optimization in the wider world and see what we can apply to motorsport.
This season, everything is new. One of the biggest changes is it's now a time-based race rather than a distance-based race.
The work in the back room is as exciting as the work in the front room. The key is how much ahead of time can you actually predict how many laps to go.
We need that information on how many laps the race will be so we can calculate the energy per lap.
4 laps to go, same energy as the cars in front.
And Genpact have been great at that this year to give us an edge in that area.
We found Leo to be particularly good and even better than our tools, getting us a more accurate number of laps faster in extreme conditions during the race.
Watch out on energy. You're about to start your last lap.
Another point where Genpact helps us is with simulator data. When we come back of the simulator, we have this big block of data which we need to learn from. Genpact extracts information from that data to us, and then we can improve going into the race.
Good lap, mate. Good lap. Keep going.
When we come to work, we're focused on winning. But when we leave, we're thinking about how do we take the work that we're doing and take that into the future. And that's the future of mobility. That's the future of transportation. That's the future of safety on the roads, and that affects all of us. Every single one of the principles that we apply in racing, you can put it to work in an enterprise.
Welcome, everyone. Josh Campbell, and I'm the CEO of Techonomy Media. There's some magazines out on the tables. Techonomy is really about convening conversations about the impact of technology on business and society. And one of the things we do is we host an event out at the Ritz-Carlton Half Moon Bay. This was our 9th year, where we bring together leaders from business, from tech, from academia, from government to tackle the big problems and the opportunities that technology is creating. So, it's an interesting time. We get to spend time with CEOs. So people typically ask me, well, what am I hearing? What are the interesting topics? What's keeping CEOs up at night? And what is the most sort of exciting trend? So when people say, throw out words, IoT, 5G, cloud, edge, and they say, well, what's the future? What's different now? I think the most interesting thing that's happening now is the convergence of these technologies. And we'll talk about that today, is not one of these technologies in a vacuum would really drive these major changes. It's really when you start to think about IoT and sensors and instrumenting just about everything we have, the ability to collect and process that data both in the cloud and the edge, and then even when we start to think about 5G, what are these advanced networks helping us make decisions quicker? So as we start to think about all of these trends converging, it's amazing to start to think about the opportunities that'll be created. And over the next hour, we'll really talk about that. How do we look at a sport like Formula E, all of the sensors, all of the data, both being thrown off by the car itself, all the external data? How do we look at that data and make decisions? So just some sort of broad thoughts to start with. How many of you have had a fitness tracker? Okay. How many of you have actually used the data and changed your behavior? All right, so I'd say about half the people. I think one of the things we'll talk about is we're at this point where collecting data is easy, changing behavior is hard. So you'll look at things like Fitbit, major lawsuits, right? People gaining weight by hitting their step count. Amazing, right? That actually, consumers would say, well, I hit my 12,000 steps, and now I'm gaining weight. What's the problem? I think we see that both at consumers as well as the enterprise. It's easy to collect data. It's easy to get the insights. But changing human behavior is the hard part. And how do we start to create new cultures within our companies to leverage that data and make, sort of those important changes? It's funny, as we were sort of talking about Formula E and all of the puns that'll come up today about driving change and all of that, you'll hear a lot of puns, I think, throughout the day. But one of the funny ones I was thinking about was, we're talking about data, we're talking about cars, and then I think about oil. And I looked back at when the first person said, data is the new oil, and you could debate now, is it truly that? But data was the new oil back in 2006. So 2006, we started talking about data is the new oil. And I think what we'll talk about today is data in its crude form, like oil, is useless. Data in a silo is also useless. We can't make good decisions as if we don't have the full picture. So context will be important throughout our conversations in the next hour. One of the fascinating things, and Sanjay and I, and he'll be up in a second, talked about this today, was everyone's talking about AI, but everyone's unsure of how to apply it to their business. And I think there's some simple things we could try to solve that may not look at the future, may not be predictive, but we could actually apply it to historical data sets. And it was fascinating. I happened to be with the deputy director of HHS a couple months ago. And we were talking about how they're thinking about AI in HHS. And I said, well, what are you guys doing? And they said, well, here, we have 70,000 purchasing agreements. So we have all these purchasing agreements across the NIH, the CDC. And we had no clue how to look across this data to see if there was inefficient spending. They found $800 million in excess spending because in some cases, people were paying 12 times as much for the same item, right? Now, this is not just a problem in HHS. This is across our organization. We have data that's locked up in unstructured formats, in agreements. So how do we start to actually make this data actionable? How do we start to unlock the power of this data? And these are all themes we'll talk about and how this data impacts Formula E, as well as how we start to think about the future of our businesses. The other thing I want to talk about is sort of changing this narrative. Changing this narrative that AI and machines will replace humans. I think one of the things we'll talk about is changing the A in artificial to augmented. How do we make how do we empower humans with better decision-making tools? And that'll be one of the things, again, we'll cover today. I think many people will say new jobs will be created. If you looked at the HHS example, no human would have been able to look at 70,000 purchasing agreements. So it's a sort of, amazing to think that we could say it's going to replace jobs. We said it about the steam engine. We said it about the PC. I think this is not a new trend. We will adapt, hopefully as humans, and be able to do a better job. Can't we all get along? There is there's an opportunity for computers and for humans to work together. And I think, again, the key will be trust in how we work with these machines. We'll talk a little about really trust in decisions. How do we take the insights and still apply what we do well as humans? We could sort of argue what we do well as humans, but usually it's curiosity. We could ask the right questions. In the other side, we use our emotions to make decisions. How do we take those biases out there? You go back to Asimov's, 3 laws about robotics back in 1942. And I think we could start to apply that. A robot should not harm a human being. It should not allow the human to come to harm. And then again, we don't want to avoid either one of those two. So the conversation today really is meant to show what Formula E is doing, how they're using this data, how the driver and the engineers, in the pit are working together to win races. So before we bring the team up, I do want to bring up Sanjay Srivastava, the Chief Digital Officer of Genpact, to talk a little about the partnership between Genpact and the Envision race team. Take a seat.
Well, for those of you that I haven't had a chance to meet yet, my name is Sanjay Srivastava. I'm our Chief Digital Officer for Genpact. Genpact is a large global professional services firm. We mostly work with large Fortune 500, Fortune 1000 customers across the world. And we help them transform their business operations using digital transformation technologies. So that basically constitutes things like artificial intelligence, which we'll talk a little bit about today in the context of racing. But we apply AI in the fields of banking and financial crimes and consumer lending and commercial lending, in insurance, in life sciences and consumer goods industries. We apply automation capabilities, we apply analytics and data science, and we apply experience. So we take those 4 capabilities And then we actually think through processes that span end to end for different areas, and we transform them. And so for us, the mantra is the intersection of a domain and the capabilities of digital. And we think it's really important to meet that intersection at the right point, so you can get the right economic value materializing out of digital transformation projects. And so we're very unique in the sense that we're fundamentally operators. We started our lives in the journey of actually being operators in these domains, and we used to and today do a chunk of that work in that processing. And then we sort of built on the digital capabilities and allowed that to intersect. And so we're very different from other companies in the space, but we love what we do.
No, that's great. So Genpact and Envision Virgin is a unique partnership. Talk a little about sort of how it came to be, and not only what formula the team is getting from you, but what you learned from now working with them.
Well, I think we came across Envision Virgin Racing a few years ago, actually at an AI event, of all things. And then Sylvain, who will come up shortly, and we got into a whole discussion about how we could work together. And it's been a great relationship. We benefit, and we'll talk a little bit about what that's been for us. Two of the things that we got attracted to and got conviction around was, first off, the notion of how fundamental data is to the journey of racing, and how much the journey of racing is similar to what we see in large corporations across the globe. I know we call it from the racetrack to the boardroom, but it's exactly that. A race is a 45-minute episode with some preparation before. Typically, large corporations go through a year of business cycle. And in 45 minutes in a race, we can do the same sorts of things that we would do in the space of a year for large corporations. And so the learning, the applicability, the reinforcement, the agile, the adoption, all of those techniques that we see happen in a 45-minute race actually apply in the context of 1 year in a business cycle. And so we got really sort of attracted to that. I think the other thing that was very obvious right from the beginning is the notion of purpose. And look, our teams are human beings, they're people, they like working on projects that have purpose. And the idea that we saw very quickly with Envision Virgin Racing and the work we do here is, of course, we're going to help the team win a race. We're going to help us get ahead. But it's not just about that. It's about the fact that the algorithms we're building today, the data foundations and the architectures we're building today are actually going to help us in the long run make mobility more secure, more affordable, more convenient, and more pervasive. And so this notion of transportation in the long run and e-mobility and working on something that's going to drive a much larger purpose is really big. And we got really quickly attracted to that. So it's been a great relationship since then.
Strategy, preparation, instinct, mind, body, team, working as one. Lightning fast decisions. Attack, outmaneuver, overtake. Predict, act, learn, adapt. Instinctively. Every encounter making me smarter and stronger. Fractions of a second the difference between winning and losing. This is survival of the fittest. This is instinctive racing.
Pretty amazing. So at this time, I want to invite the managing director of the Envision Virgin race team, Sylvain Filippi, and one of their drivers, Robin Frines, up to the stage to join us for this conversation. So let's give a round of applause for Sylvain and Robin. So, I think about half the group was familiar with Formula E before getting this invite. which is great. Because originally when I started working with you guys, I really had to understand what it was. But Sylvain, talk a little first about, what the sport is and how you win. Because I was uniquely sort of thinking, okay, it's great. It's how fast can you get around a track and get the checkered flag and I win. But, talk a little about how different, this sport is.
Sure, that's a big question. How much time do you have? Okay, the short answer, in my job you have, so instinctively you would think fast car, good drivers, right? Which is fair, you need these two things. But in Formula E especially, for those who are familiar with motorsports, the challenge is much higher. My life is a lot more difficult than if I was doing the same job in other series. The main reason is that Formula E is a one-day event. So we do all the free practice, qualifying and racing in one day, which means there is very little time between sessions to take the learnings from the data and then improve if you're not doing great or whatever.
And that's interesting, but explain in Formula One how compressed that is, the difference between traditional racing when you say one day, how does it typically happen?
Yeah, most championships, whether it's touring cars or single series, whatever, are over at least 3 days. So you would have free practice over 1 or 2 days and qualifying the day after and then another day after that for the race. So you have all afternoon, all night if needed to look at data. You also have many, many engineers to do that. We'll talk about it later. So anyway, Formula E is a very condensed version of normal motorsports. And the theme that will go throughout today is efficiency. Everything we're trying to do is to be efficient. So that's one of the ways of doing it. So to answer your question, you need a fast car, which we can explain in more details what that means. Good drivers helps, but also team, I need the best people, because ultimately we'll talk about this. AI doesn't replace everything. You need good people to make the right decisions. And you need the good tools, infrastructure, IT, procedures, processes, all the back office stuff that is less glamorous than drivers on stage, but it's really super important. And as part of my job, I believe it's one of the things that we do extremely well in this team, which is why we win so many races, because we look at all these aspects. And obviously with Genpact, we work on this together. Right. So yeah, many aspects, and that's what I think makes racing interesting, and a good case study for other applications, because you have so many moving targets.
So Robin, sort of you drove Formula One before?
Yep.
Sort of you come into Formula E, we've heard now all the sort of nuances and differences in the sport. As now the driver sitting in the seat, talk a little about the difference in experience that you have in this sport, especially as it pertains to having someone in your ear that's looking at a lot of data and feeding you information. I mean, how different as the human in this equation is it, from Formula One to Formula E?
It's what Sylvain already mentioned before. Formula E, it's all in one day. Formula One is in 3 days, sometimes even 4 days. So every mistake could be very crucial. We have FP1, FP2, qualifying and race all within, 9 hours, I would say. So if you crash in FP1, you will probably lose FP2 and you will lose a lot of data heading to the qualifying, pretty much not knowing what's going on. And that's the same thing going even more backwards. If you put the car on the ground in FP1 and you're not well prepared, you can be on the back foot, but you could be on the back foot for the entire day, for the entire weekend basically. So that's why the weekend for us starts maybe a week, maybe even 2 weeks before the race actually is going on. With all the preparation we're doing, all the simulator work we are doing to get the maximum preparation we have for the race, to knowing if we put the car on the ground in FP1 that we have a good base where we can start from, because we cannot change the car from one side to the other side from FP1 to FP2 because you only have 1 hour or 1.5 hours. So that's why it's so important to start well.
And when you talk about the car itself, I think the unique thing, we talked about the hardware, right? So a lot of it we'll talk about is humans, machines, software. The hardware, there are certain components that are standardized, right? So the battery is one. So as we talk, we have some auto people here who are thinking about EV and the future of mobility. Talk a little about sort of what these learnings, Sylvain, from battery technology, how that will translate back into, some of the more sort of commercial businesses that are represented here.
Yeah, sure. To explain that, I need to go back to the beginning. 6 years ago, when we started Formula E, I was one of the ones starting this team. So people thought were a bit crazy at the time. The whole point of Formula E was to not just create yet another motorsport series, yet another entertainment platform. The idea was to do that with a purpose. And the main idea was, it was clear for a bunch of us that the whole world and the whole mobility space was going to go electric. But I'm one of these people who believe so strongly in the technology and what the technology can do. But what we needed to do is to give a boost and to give some momentum to that technology. And we are not reinventing the wheel here, first pun of the evening. We are using motorsport for what motorsport is great at, which is to accelerate innovation. It's been all the innovations in the cars you drive come from motorsport in some way or another, dated back to from the 50s and so on. So we needed to apply that system to electric. So with the FIA, I think one of the greatest things we've done is to keep the regulations relatively simple and really well structured. So in a nutshell, if you look at all the cars, they look all the same, not because we want it that way, but because it's the most efficient way of doing it. There is no point, like Formula One, spending hundreds of millions of dollars every year to try to change the bodywork, create more downforce, improve the aerodynamics. Sure, it's fun. Sure, it makes the cars go faster, but it has zero relevance to road cars. So we'd rather take that same 100 million and spend it on electric technology that actually needs to be improved and needs to trickle down to road cars. So bodywork's the same, chassis is the same, battery is the same for now. That's mostly for sporting reason, because if we start to develop a whole bunch of different batteries, you could come up with one team that has figured out a way to have a lot more energy and they'll win everything. They'll be a bit boring. So, but at some point there will be some development on the battery side. But everything else is open. So we designed the whole powertrain. Everything that makes the car move is open. So motors, inverters, electronic, differential, transmission, all the software, all the high voltage stuff. All that's new, basically, with electric cars we design. Yeah.
So that's obviously the one learning as we talk about from the racetrack to the boardroom, how some of these hardware technologies, software that you're developing is being applied into some of the mobility ecosystem. Sanjay, talk about again as the learnings that you've taken. You said sort of this compressed decision making, right? Sort of CEOs and decision makers are sitting in a boardroom. They're inundated with the fire hose of data that we all talk about. They need to make intelligent, informed decisions. How is this, what you've been doing for the team, how are you starting to see the benefits to your corporate clients in applying that into their businesses?
Well, I think a couple of areas, Josh. Look, I think right off the bat, if you think about it, we have to develop AI and data science techniques to come up with predictive responses in situations. We'll go through that in a minute. But the underlying data sets, if you just start, so just taking some specific examples, 100 sensors, data coming off of those sensors, the car's moving around. You've got a fan base, an audience that's spread around the world, and then we sort of track what their preferences are. You look at what the competitive drivers are doing, and you want to assess and understand that enough to be able to predict what they're going to do in different scenarios so you can come up with appropriate responses. And then when, for instance, we look at information associated with the track itself, so you're looking at satellite imaging, you're looking at weather patterns, and you're trying to, for instance, these cars, before a race, you go through about 10,000 different simulations in it. And so you have to take an image from a satellite of something in a road, a bump, and you have to translate that into what it feels like when you make that turn in a car, and you have to get that sensation to be able to simulate it properly. And so if you think about the amount of data science that needs to go in and the amount of data you need to be able to touch, it's fundamentally the same problem we see in large corporations. There's tons of data. Most of it is locked, i.e. dark. They're sitting in places that you're not able to access in a structured way. And then the work is around figuring out what data you need to access, how do you transport it out, what do you keep at the edges, what do you bring at the core, how do you normalize, how do you transform, and how do you convert it into algorithms. And so we see some really interesting parallels in the work we do there, and it's been a big learning in that regard. I'll take the other one because you touched on it. It's this whole bit about augmented intelligence. It's this notion of man and machine. It's this balance between prediction and judgment. And there's a whole discussion around AI and the narrative around AI around, is it a replacement technology, is it an augmentation technology? And for us anyway, I think the line is very clear. We think of AI as something that is essentially a prediction machine. Given a situation, it will predict what is likely to happen. A self-driving car doesn't really actually drive. What it does is It says, at this moment, with these variables, I'm going to predict what the human driver would have done, and I'll do the same thing, right? So it's a prediction machine. But every time you do that with an AI, and you come up with a prediction, you actually have to apply judgment to make a decision whether to use that prediction or not. Then you have to act on it, in this case in racing, but in business life with actual business decisions we make. And that interplay between man and machine, that ability to be able to drive predictive predictions and predictive results at high accuracy, but then present it in a way that the human in the loop is able to take advantage of it and compels itself to take action on it, and that action actually drives results, is a really important area that we study a lot. We spend a lot of time thinking about it. And we see that across larger enterprises, exactly the same thing. And so I think the work we've done there, it sort of really overlaps quite nicely.
Right. So Roman, so we talk about the augmentation of human behavior, right? So you're still sitting in the car. Ultimately, it's your decision, right? It's your decision. And at some point I want to talk about, it must be a fascinating conversation when you're hearing people give you feedback. And, you know, when you think about making that decision, obviously you have different inputs than just what's coming in, you know, from the engineers. Talk about that, your decision-making process. Again, similar to an executive getting the insights from their data team and saying this is really what the data is telling us to do. You know, do you sometimes have to struggle with what I'm hearing isn't what I'm feeling in my gut? You know, the word instinctive kept coming up in the video, and I said, well, is this really instinctive? Like, do you know, talk a little about sort of how you ultimately make decisions. Do you have to sometimes choose when not to use the information or when to use it?
Yeah, exactly. I think the first race weekend in Riyadh was pretty much a perfect example, because we have a tech mode, which you drive over 3 loops and you have 35 kilowatts more energy to use, more power to use for a certain amount of time. You only can use this 2 times in the race. Depends, sometimes they change it around, sometimes 3 times, but most likely it's 2 times. So, and as it's outside the line, you lose about 1.5 seconds, 2 seconds, so you lose a position and you will lose ground. And as you are fighting with other drivers in front of you or behind you, you don't know what the other drivers will do. Do they go on attack mode? Are they on attack mode? Am I on attack mode? So the engineer can tell you, like, you have a gap from 2 seconds behind you, and I was fighting with the guy in front of me, and seeing him going on attack mode, knowing I will have his position, so I will need to defend. So I knew, like, even though my engineer told me to go over attack mode, but the guy in front of me went, so I had his position, and then the next lap I used quite more energy to stay in front of him to go over attack mode again. So I gained the position, which on prediction-wise, you know, you have no influence of what other people or other cars or other teams do around you. So that's a part of instinct you have as a driver, influence during the race, which is a good thing, but also could backfire you through the race. Because if you take your own decision and every calculation we had before could be in danger of making to the end of the race. So it's all a calculation, and as a driver you have the last call, obviously, but knowing in your head that you need to make a decision, like, you know, which is a smart move, could be a smart move later in the race.
And when you say make it to the end of the race, that's you have to manage your battery to make sure there's battery at the end, right? So again, very hard for a human to be calculating the numbers and saying, okay, am I going to have enough power? That's where the role, you know, sort of the engineering team comes in. So Savan, again, you know, now the flip side, you sitting on the side watching what's happening and you feeding information, you know, how challenging is it sometimes as you're feeding data to someone that's in the seat ultimately choosing to use it or not, when they make an instinctive decision, you know, do you typically go, well, the data's telling us, you know, that you should do this, and you're not listening? You know, how is that dynamic?
It depends on what it is. Sometimes, the rule, most of the time, the agreement is that if we tell our drivers to do something, they'll do it. Because we have more data, we can see better what's happening around them, we just have a lot more information. However, your example was a good one, to be fair. Sometimes there's stuff we can't anticipate everything, right? So it's back to simulation, right? Robin was absolutely right. We prepare for weeks For a 45-minute race, there's 10,000 of man-hours that go into preparing that, whether it's on the energy management, on the strategy, on the simulation, on all these things we do. So when comes the race time, you have a whole hierarchy of decisions, right? Some of them, if it's around, for example, the battery side, the energy management, or car systems, or things like that, 99% of the time, the team engineers will be right. We know what's happening. We inform the drivers, and it's not up to debate. It's what's happening. And we'll tell the drivers to go into that mode or do whatever different things. The example that Robin gave, which is purely the driving sporting side, that's the one area where, for sure, we can't simulate everything. That's the beauty of motorsport, right? Otherwise, it would be boring if it was predictable. So we try to predict most of the scenarios of what could happen, but we can't predict everything. It's mathematically impossible. So that's where the instinct comes in. And ultimately, this is exactly what you described, right? Like, for us to do that accurately as an engineering team, to prepare and then during the race make the right decisions, the only way we can do that is through the work we do together to augment, basically take my very, very good engineers and make them superhuman engineers. And the way we do that is by using some forms of AI, some algorithms, some coding, some software. We have whole sort of software that run in parallel, that we test, double test, triple test to make sure they are robust. And all these things we have to do to make sure that when race time comes, nothing's going to go wrong. And if we execute what we planned, more often than not, it's a good result.
And how many races in a season, typically?
14, yeah, it's going to go to 15. We're going to cap at 15, 14 this year. Yeah.
And that's over how long the season is?
7 months, yeah. We started in Riyadh, and it's going to go typically from December to July. So a race every 2-3 weeks.
Every 2 or 3 weeks. So in between those, talk about closing the loop, right? So now you have historical data. Sometimes, you're on the podium, right? 50% of the time, that's through this relationship. Sometimes you're not. Do you run the simulations following the event to identify and talk about how that's similar for companies as they're thinking about, we're coming into holiday. Anyone in retail is trying to plan product mix and where they house their goods, right? And they're using similar analytics, right? To say, for me to, Amazon's thinking if I want to ship and get stuff there in time, and then after the holidays, they have to actually look back. Talk about sort of that role and looking back and closing that loop to make sure that everything was optimized.
I think the learning cycles and taking advantage of that is key and critical to getting this right. You used the word instinctive earlier, and I think, when you first hear the word instinct, it's all about the instinct that we have, that we've evolved as a species over the evolutionary curve that we've gone through. And that's the sort of stuff that allows you to be able to interact with people because you have an instinct about people. And that's hard-coded because it's evolved over generations. The challenge for large enterprises is that it's very complex business environment. It's fast-changing. The ecosystem around it is evolving. The client base is changing. It's a very different environment. And you can't bank upon hundreds of generations of hard-coded, instinctive, sort of recursive knowledge to be able to deal in business environments. And so what we try and do is we have to find ways of leveraging the data, applying artificial intelligence, applying data science, automation techniques to be able to harvest that and have the same kind of response mechanisms that we're used to as human beings. And so I think the word instinctive in the context of enterprises is just that. It's not that everyone needs to make a decision in a blink. It's about how do you harvest the information that sits in the ecosystem and in your own environment, much in the same way human beings, we have over the generations we've lived, been able to program ourselves and be able to bring that to the enterprise so they can make decisions in an instinct. In racing, one of the biggest things we learn is every race is different. I'm going back to last year, we had, the race in Paris had, it was a rainstorm and a hailstorm and sun at the same time. We got in Santiago and the temperatures were off the roof. It was off the charts. And every single time, I think in Berlin, I was with you in Berlin on the, we were racing on the Tempelhof, is that the airport?
Yeah, the old airport.
The old Berlin airport racetrack, runways, right? So the actual track, the friction coefficient of that runway is very different than driving on a street because, they're built differently. And so every single time you race, something has changed. And you have to be able to use that as a reinforcement learning opportunity to be able to train your models further and get it better and better and better. But actually, that's what we have to do.
So how do you identify those proper data sets that will influence, ultimately how the race goes, right? So again, keeping wanting to try tie this back to business, right? Sometimes it's simple, but to your point, you mentioned sort of the surface of the ground, the climate. Does everyone think that they have different variables that need to be factored into those algorithms, and how unique is that combination to what you guys have built?
Well, listen, I think one of the things that we've seen in racing, and I think it applies to corporations, is that you have to start with a simple objective and go for the simple problems first, right? So I think Sylvain talked about it, and the key point in e-racing is the fact that it's not a timed race. In other words, we're not saying we have to go this far, how fast in time can you get there, right? So this is not about speed, it's about efficiency, and it's about predicting how many laps you have yet to do so you can conserve your power. And to the point you were making earlier, you don't want to end the race without power because you'll stop and you won't finish. Equally, you don't want to end the race with 30% of your power left because you haven't exercised all the flexibility you had. And so much in the same way, when we think about applying that to sort of a business environment, now whether it is working capital, and how do you optimize working capital in a large manufacturing company? We look at financial crimes for large corporate banking corporations and think about how do we spot those patterns. We look at supply chain optimization and think about how do you have inventory at the right place at the right time when you need it. Aircrafts, as we know, the aircraft engine model has completely changed. That industry has gone from selling aircraft engines to selling aircraft engine miles flown. The entire industry has evolved. And the reason it's evolved is the data that sits on the back of those aircraft engines can be used to predict the behavior of the engines and the supply requirements or the support that's required of the plane. So the people that have access to the data can actually predict what are the 2 or 3 spare parts that will be required for that engine when the plane takes off from here to Mumbai, as an example. So when it lands in Mumbai and needs those 3 parts, we're not sitting there for 3 days waiting for it to be sent out. And so that's allowed for the industry to completely change. And I think that comes from the back of the same thing. It's the data, it's the analytics, and it's starting with the end problem and solving for that end problem first. And then you make decisions on what data you need, what algorithms you need to build, and how do you refine it.
Right. So in a minute, I'm going to go to you guys. But I want to ask Robin, we're sitting here talking about data and technology and not as much the art of driving. Does that part excite you, scare you? The evolution into this point where it's become, can we boil it down to, data and external factors? Do you start to feel threatened by what technology is doing? Do you feel empowered by what technology is doing?
I wouldn't say threatened at all. Every data we have makes us better. There's a lot of things going on in race. As you said before, we are speaking with the engineers all the time, pretty much every lap. And if you have certain data which other drivers or other teams doesn't have, you have an advantage over them, which is all that matters. So it all comes back again to the preparation, simulate the work. That's where this data starts from. And if something happens, if something changes in the race, and we do like maybe 50, 100, maybe even more race runs to predict what could happen if something will change during the race. So I wouldn't say it scares me at all. It challenged me, for sure, but it also could predict of what's happening on us and could have a big advantage for us as well.
Right. Questions? Do we have anyone yet? Remember, I will wind up calling your names. John, I was going to call on you anyway. So, John's down there from Cradle.
So, the question is: so Genpact is working with Envision Virgin Racing. So, are there other companies like Genpact that are helping other teams? And could this escalate into where all teams can have some sort of AI or augmented intelligence to support the driver and the race? And how do you see that evolving over time?
I think I would say that, right? But we are very much pioneering this, as far as I know. Sure, I don't know what all the teams are doing, but having a rough idea, even in Formula One, which used to be the cutting edge of data, but now Formula E is simply because of the nature of the cars. If you come to my workshop, you'd expect a lot of cars, a lot of parts and all this stuff, right? But actually, you come to my workshop, it looks like a lab. It's just software engineers everywhere. One reason is that the car's going from race to race anyway, so once the season has started, we don't really see that much. But also, pretty much all the work we're talking about here, it's on the laptop, it's software stuff. But no, really, back to the beginning. When I started this team, it was very clear to me anyway. I had to go back in history. When we started Formula E, most of the teams that joined the championship at the beginning were existing teams from other championships, which gave them an advantage. They were already a team, they had people, and so on. For us, we were a brand new company. We were 3 of us at the beginning, and the first item on my to-do list was build a team. So I had to hire people and do that stuff. But it gave us a huge advantage in the way that we could shape that company the way we wanted. We didn't have all the legacy of the other championships that they would be racing in. So that allows us to mold it in a proper way. And very quickly from the beginning, it was very clear. Most of the performance that we'll get from these cars is based on software, either the embedded software in the car or all the stuff we're talking about here, the information behind. So that allowed us to think creatively, having a disproportionate amount of software engineers versus mechanical engineers, and then starting to talk to Genpact, then we augmented that many-fold by just using Genpact's resources and knowledge. So we are at the beginning, but for sure, everyone's going to catch up, right? And informally and in other sports as well. I think many other sports as well can benefit from data. Motorsport is just an iconic way of demonstrating because we just have so much more data than any other sports. And I think it's a good case study. It's too much detail for now, but if you're interested, if you came to see us, for those who like these kind of things, I mean, our databases are just beautiful, right? Like this is what we do every day, right? So there's no dark corners of data with us. Every single thing we have, it's getting. So it just shows you the art of the possible, right? Like if you have a lot of data, really well structured, and with some good engineers trying to be innovative about it, you can do some incredible stuff. And that's why we are a good case study. But yeah, fast forward a few years, I don't know, your guess is as good as mine, but I think the sports industry, for sure, it's going to change. Because you can, as Robin said, it's an advantage, it's an edge. If you do this better, then you'll get an advantage over your competitors. And then,
What you're saying, Sylvain, is so true for racing in a way, I think what you're doing relative to the other teams out there. But perhaps it's not that different from what we see in the industry, because what we find pretty much in any industry is that the leaders think of themselves as, there's a saying that goes, right? You're a technology company, even if you didn't know it. And so most of these leaders are fundamentally technology companies. They happen to be in the business of lending money. They happen to be in the business of moving goods from point A to point B. And I think that's kind of, as I just hear you talk, the language is, the examples are very different, but the language is very similar, which is you're starting to think about data and architecture and software and automation and AI. You happen to be in the business of racing. And we see that all the time in the industry as well.
Yeah. And I think almost we've seen this over-indexing to every company saying they're a tech company and losing sight of what is their core mission and value, right? I mean, there's still a sport here. It's still about winning. It happens to be enabled by technology. And to your point, you're doing the most efficient way possible by partnering rather than trying to build your own modeling systems. And I'm sure there's others. But, you mentioned, we've talked a couple times, I brought up the point earlier around structured data, right? So, you mentioned structured data. I think the number you originally gave was 100 data inputs. Is that 100 being thrown off specifically by the car, or is that including external factors as well?
Oh, no, it's way more than that. The car itself will generate, I think there's 180 sensors, so at 50 hertz, whatever, that will be a lot of data. But that's only just the live car stuff. Like you talked about earlier, after the race, do we do the simulation? Yeah, of course we do, because it's all about correlation. So we have a whole simulation phase when we try to predict what's going to happen, then the race happens, then we learn from it, we correlate back, and you do that 10 times and you end up in a really good place. And that's tens of thousands of data points, it's car stuff, right? But if you want to model a car on a simulator, you have the chassis side you have to model the overall vehicle dynamics, you have to have a very precise tire model, you have to have an extremely precise powertrain model, so where the weight is, the energy, the power, all this stuff. Each and every of these models has tens of thousands of lines of code. So you can see where it's going, right? It's huge. So when earlier you asked how do you know which levers to play with, right? It's hundreds of thousands. But the key is to know your ecosystem. The beauty of motor racing is that, sure, there's a lot of data points and a lot of levers to play with, but we know the whole ecosystem. So we know diverse models and we know what we can improve, and then after a few iterations, you slowly get there. It's a never-ending job, but you quite quickly get to 99.5%, and it's the last 0.3, 0.4 that will take another.
So this goes back to no human would be able to process that many data points in the time that's needed, no matter if you're the best driver in the world, then you're prioritizing what is the data that's important to me. Whereas using, the algorithms that you're building, you're just, again, informing the driver to make a better decision.
Josh, there's a flip side to it as well, which is just like no human would be able to process all this data, no AI without the benefit of that judgment around, you've got so many variables, and which ones do you target first, which ones do you go after, and how do you organize your approach? No AI would be able to do it completely by itself either. So this is where the human in the loop is such an important component to how we think about AI, and why we believe AI is an augmentation technology, not necessarily a replacement technology.
And it's a management decision for me as well. Like, we don't even talk about reliability, we take it for granted, but we also have all these things. We just talk about performance, but I also need to make sure the car is functioning properly. So there's all sort of software embedded in the car to, instead of monitoring all these sensors all the time, we have an alert basic system, right? So if we don't get any messages, we assume it's fine, and then if anything goes wrong, we get an alert, and then we can look into it. But I have to make a decision. I'm only allowed, by regulations in Formula E, which is an interesting point, I'm only allowed 20 operational staff at races, which is about 20% of what they have in Formula One. So it's very tricky.
20%?
Yeah, if a good Formula One team would have 100, 120 people at the track, I only have 20 to run these cars. So I have typically about 12, 13 engineers, 7 or 8 mechanics. So that's not many engineers to do all this stuff. So, but I have to make decisions. If I wanted to be very safe, I could allocate 3 engineers to just look at reliability and what we call the systems, the controls, make sure the cars are behaving properly. But then I don't have enough people to do the performance stuff. So I decided to only have 1 on reliability. And all the other guys looking at the performance-related stuff. And so far it's working out fine. But that means you need to have all the systems in the background to make sure you can get away with doing that. So there are all sorts of decisions like this we have to make.
Another question, anyone out here?
So I do hear you guys elaborating greatly around the predictability capabilities around the AI and some of the capabilities, again, that enterprises leverage from that perspective. A lot of the enterprise customers that we're working through, there's 2 more phases that we usually like to really talk about, which are, of course, optimization and then, of course, automation. Right, and then those 2 points, can you guys talk a little bit about those segments on your guys' side? Meaning, from a historical perspective of the amount of data that you gained, what new optimizations has it done? Or to his point that he was making on his example of having to maneuver, is there an ability to use enforcement as an example in an automation perspective that would allow for that kind of conversation to happen?
Maybe I'll start just what we see, certainly in boardrooms and large corporations. I think both of the points you raised, optimization and automation, are really key. Let me start with automation. Unfortunately, too often the point of view is that we'll just bring in AI and we'll come up with the algorithm and we're done with it. The reality is that it could be farther from the truth. Most AI programs, when we implement that in an enterprise, and we've done this in many different industries, your prediction accuracy is never going to be 100% off the bat. It's going to be probably in the 80% if you're really good at what you do. That's not a bad way to start, by the way. It's just you need to know it's 80%, because then you need to have an exception management mechanism to deal with the other 20%. And what's more important is, as you deal with the other 20%, you have to drive a reinforcement learning loop back into the AI algorithm development process to be able to keep going from 80 to 85 to 90 to 92%. And so this bit requires automation. This bit requires an industrialized structure that houses the AI algorithm, but then manages the entire process so that as you go through the process, you learn and you feed it back and you make your AI algorithm better and better and better. And by the way, it's even more complicated because eventually there's drift in the models, there's drift in the data, and so even if you had it right to start with, it's going to drift off, and so you need this cycle. And so getting the automation right is super critical, and I think one of the biggest concerns I have is when you first look at it, you think, oh, we'll just implement AI and we'll be done and over with it. And the reality is you have to implement AI, but you have to think about automation in a way that you can actually keep refining the AI. That's super important. I think the optimization actually brings up another another important aspect. And I think for us, the learning has been that experience is really important, because AI can only predict, and hopefully at high accuracy predict something. But that prediction has to translate into action through judgment. In racing, it's a prime example. You have to make that decision in a split second of an instant, right? In business, it's probably not that different, because when push comes to shove on the shop floor, you do have to make a decision at speed. And so one of the learnings we've had is, how do you present the predictive insight in a fashion? How do you think about the experience of the user on the backside of it so that they can absorb that input and be able to act on it? And, we've had discussions on sort of how to present feedback, and we've designed a very specific process around in the race, how we come with insights, who we transfer it to, and how it goes on to the driver. And that's in that specific environment, so we want to make it work. But in most business environments, it's exactly the same, and we have to think about the experience of the individual that's going to be getting those insights and enabling her or him to be able to make the right decisions at the right point in time. And that's all around sort of the expanded ecosystem of optimization, because without that judgment, without the action, actually all the predictive insights I can give you is actually useless.
But I think to the question, pushing these automations out from based on the insights, can you actually push in real time changes to the suspension, or can you from your set of engineers bypass Robin making a decision and actually say, this is what's going to be better for the performance of the car, I'm just going to push it to the car, and the human, does that happen in sort of real time?
Yeah, a lot. That's what I'm talking about earlier. There's thousands of data points and either coming from the car to us or us to the car, and most of these are automated, and they're just getting better and better all the time. If they were not, we couldn't even operate these cars. Like, a good old mechanical engine, that's easy. You just start it up and it goes. I make the joke with these cars, if we, without all this automation stuff, the car wouldn't even leave the garage, it wouldn't even work. But the challenge is how to do it more and more and more. The more we automate in a really reliable way, the more it frees up our brain space for other stuff. And that's where you have to be careful, right? Because as you say, the more you automate, you have to be careful you don't go over the threshold where we start to get things wrong. So for us, we have an iteration process where we work now pretty differently to how we used to work 2 years ago. And 2 years from now, some aspects will be even more automated, which then will give us more time to do other things. But we do that bit slowly and gradually to make sure it's always a benefit, right? We could quite easily step over the mark and then automate something, and then the car does something really wrong and it stops or whatever. That could happen really easily. So, and then the simulation work we do, we have something called lab sim, which is the simulation work that goes on the computer, basically, simulating the model, the car going on the track. And then we have the driver in the loop simulator, where Robin has the joy of driving these things all day. And that's the same. We optimize all the time. Every time we come back from a race, we have more data, we can compare to our model before the race, and that keeps improving. And we also automate the accuracy of the model. So yeah, these things are commonplace in motorsport. But again, Formula E is a good place to talk about it, because it's now probably 90% of what we do. Like, the car being the same chassis, being the same everything, there isn't much hardware stuff we do, apart from developing the components in the first place. But once that's done, and we have the car to race with for a year, pretty much everything else we do is software-based.
For all of us who've built massively complex systems, there's always a moment of surprise, wow, we never even considered that bug or circumstance or need for data or wacky factor of a person who's using it. What was your biggest wow, either as a driver or creator of it, that really made you step back?
You'll take that later. For us, there's been quite a few over the years. The main was when we started, actually. We came up with this LEO software, lap estimation optimization tool. And that's when the regulations changed from a distance-based, the race will be 46 laps or whatever, and now the races are 45 minutes plus 1 lap. And it's really tricky because it sounds simple, right? But if you say, okay, the race is 45 minutes plus 1 lap, obviously each track has different length, each track has a different layout, different average power, different average lap time. which means it can actually be very tricky to estimate how many laps we're going to do in these 45 minutes. We can, if it was just us on the track by ourselves, then it's pretty easy. But with everyone else thrown in, plus the weather, plus all the stuff that can happen, it changes all the time. And if you want to finish the race with zero energy left in the battery, so to give you an idea, we have 52 kilowatt hour in the car, in the battery, and we try to basically cross the line with 50 meters to 100 meters worth of energy. That's equivalent to 0.0 something %, right? That's insanely accurate. But to the point, if we finish the race with energy left in the battery, it means we could have gone faster. So we don't want that, but we don't want to stop before the line either. Anyway, so we've developed this tool, and so for something that seems a very basic mathematical problem, it's actually quite tricky to do. And then we actually won a bunch of races last year, simply because we got it perfectly right. And some even really large teams with many more resources than us got it completely wrong. So that was fun. But don't take it for granted too much, because we could get it wrong one day. But yeah, there are many examples like this. Yeah. Don't know about you.
Well, I mean, we can see it as in Mexico what happened to Nissan.
Yeah.
They did the whole race, and then with 2 laps ago, they figured out, oh, we have to do 1 more lap than we calculated in, and then they basically stopped with 1 lap to go, while being in podium position, I guess.
Yeah.
So hopefully, well, as Sylvain already mentioned, we have a really good program, computer running behind it to predict of pretty much what's happening around us. We as drivers, we are looking forward, but the team behind us has the complete overview of what's happening throughout the whole race, which we overly don't have. So we always pretty much listen to the engineers of what to do, minus lap, plus lap, to have all the calculation which we have on the steering wheel of what we can do with the car, of how much energy we have to spend or use or save or whatsoever to predict what's happening.
I will add one thing, maybe stepping out of racing for a minute, building large complex systems and applying it in different fields. I think the big aha is really that bit about, it's 45-minute cycle, right? And that gives you an iterative, agile loop, because you can try something, 45 minutes, you know what it is, in a real life, real environment, and then very quickly use the results of what you learned and then adapt to the next one. And I think what it does at a business partner, at an ecosystem level, is it brings credibility, because you can start seeing those small things add up quickly, and the adoption and the change management and the desire to sort of invest more and to use the results more just amazingly goes up, right? And I think it's been a big aha for me, actually, and we haven't discussed this ever, but it's been a big aha because mostly I get involved in really long cycle projects, and it takes time to iterate through that. And over the years, we get to the right point, but a race is very different, because in 45 minutes, you get through an entire cycle.
First of all, I really...
Yeah.
Hello? Yeah. First of all, I really like this panel that brings the user perspective and provider perspective on the application in racing, which is pretty cool. I have a two-pronged question. So when I was heading Siemens technology business, which is tech ventures for this $80 billion global business, including e-mobility, my team have ID'd about over 100 predictive applications across different industries. And in that, we actually found out, the predictive engine, analysis, those are not the hardest part. We have hundreds of choices, from different vendors and providers. But the 2 major choke points, we talk to, customers and users. One is actually, it's the 2 ends. One is the data input, right? The structured data, the unstructured data, and the dirty work about how do you clean them so that you can apply your predictive engine. The other part is the other end, which is the human-machine interface, which you talk about experience. But how do you design HMR, in that the user will find it usable and then it's intuitive so they can make that fast decision. And these are the 2 choke points for the driving AI or predictive, adoption. So my question to the panel, there's 2 prongs. One on HMI side, you talked about a little bit. I want you to go a little bit deeper, expand. What are the collaborative process in the 3 of you or your team that work to build that ultimate interface? So, and Robbie, can you trust that, can use that to make split-second decision, right? So that would be very interesting. You can just expand that a little bit more. And the other side, I want Sanjay to mention about on the data cleaning part, what you see, because you have experience in a lot of industry. what are some challenges you face and how do you solve that? And so that's my two-point question. Thank you.
I'll start by, it's a really good question, and I think what happened at the beginning, correct me if I'm wrong, is that we identified that what we do in motorsport, in Formula 1 especially, would be a fantastic case study to showcase that. So on the plus side, I don't think, correct me if I'm wrong, there was that much cleaning to do because of what I explained. We're pretty on it already anyway, but fully realizing we're not a normal business, right? Like it's, in a way, it's easier for us because everything we do is data-based. So the data was there, pretty well structured and so on. But because of this very fast cycle of the race, and then 2 weeks later another race, and then 2 weeks later another race, we had to adapt the way we work. And Sanjay basically realized that, and he has kind of created a task force, a team, that's basically become really, really close to my team. So his team is an extended version of my team, basically, and they work really closely together. And that's the only way to do it because motorsport is a really niche way, and this specific problem is very niche. So you need to really understand not only what we're trying to achieve here, but also the bigger picture. That's really important. So there was a huge element at the beginning of education, both ways, for his team to understand all the intricacies about motorsport, Formula E, and the strategies we're trying to achieve, and then for us to understand what we had to do to then leverage what Sanjay's team is doing. Because I had a bunch of pretty good software guys, but not to the level that Sanjay does. So yeah, there was a lot of that happening at the beginning, but then quite quickly, that's what we said earlier, quite quickly, the results came, really, because that's what happens, right? When you get the right competence and starting working together really well, this is what happens. And the beauty of also a setup like this is that, again, realizing it's much more difficult in large companies, but there's no inertia, there's no politics. Like, everyone's working on one clear common goal, right? Which is to win races and develop these tools to do that. So there's no noise. You just focus on the main point. So yeah, that's what I've witnessed.
So how are you feeding the information? I think to the question to Robin when he's sitting there driving, right? Is it audio? Is it you start to think about what is that dashboard figuratively and look like? How are you transmitting that information?
Dashboard is full.
Yeah, the chain is really long, right? Like, as I said, there's so much data, thousands of inputs. So a lot of it digested comes to my engineering team. My 12 engineers, they are split into very different roles, performance, reliability, strategy, simulation. They all have their own stuff. The data is filtered down to them. Only they really, during the race, when it's really critical, they really only see what's really relevant to what they do, otherwise it would be overwhelming. And then you have a race engineer in the middle that's kind of doing the summary of all of that, and then hopefully making the right decisions. And hopefully I'm in the back. If all goes well, I never have to do anything. If things start to go wrong, I need to intervene, but it's rare. So and we have our own dashboard to do all of that. And then the sharp end of all of this, of course, is the driver in the seat. And ultimately, there are only two ways to show information to Robin. First one is on the steering wheel. And if you see a picture of what it is, it's pretty scary. Like, I don't even know how you can read numbers on these things. It's so small, and it's, I don't know how you do it. There's pages, so, one screen is not enough, so Robin has to scroll through pages to actually change the right thing. That's the one thing that is really incredible in what they do. And then the good old radio. That's the only other way.
So you're getting audio feedback, numerical data, as well as some type of visualization.
Yeah. It's good, it's easy, because
like this, I don't like this. You get involved in these design cycles so that you have the ultimate HMI, design machine interface for you to
Robin, the drivers, they come in at the last 10%, right? Like, everything we do is around the models, the strategy, the energy, all that stuff. That's the engineer's job. We'll do all that. And then at the end, when it's about execution, then he will jump into the sim, the actual one that you can drive, test all of that, make sure it makes sense, give some feedback, then we reiterate again, and then we go racing.
As you said,
made some comment,
it's as you said, can I trust the systems? Well, basically, we go back to all the preparation we do because we have a simulator we are driving in for 2, 3, sometimes even 4 days, and we are testing those systems. So, for example, the engineer can talk to me all the time in the race, but for example, it could happen that the radio breaks down, and I cannot communicate with my engineer, so I don't know what's going on. So all the information I have on the steering wheel, I have to trust that it works, and that's what we all do in the simulator. So we really test those systems we're having to have no radio and throw out a safety car after 4 laps, and the system has to deal with it and predict what's going to happen. So that's why if I'm heading to in a race and things can go wrong, I don't really stress about it because we did it already many times before. So that's why I really trust what's happening around.
So the big word takeaway is the trust, right, in that split second. And then the way to solve that is using simulator many times over.
Yeah.
So you, as a driver, develop that kind of trust of these prediction engine, right?
Exactly. I know it's going to happen because I did it before and I'm used to it. So that's why I fully have trust in the system which are behind it.
So real quick, Sanjay, can you comment on data cleaning part and then move on?
Yeah, it's a great question, first off, and maybe I'm going to step away from racing because I think in the enterprise world and large corporations, the problem is magnified multiple times. First of all, on the data side, most companies haven't necessarily started with data as the foundation of the business, the way I think we're talking about over here. And so there's so much data that's sitting that is basically dark. They're sitting in Excel spreadsheets, they're sitting in Word documents, they're sitting in PDFs in large corporations. And being able to access them and then light them up and use them in a structured format is, I think, 80% of the battle in building AI systems, right? So I'll give you an example. One of the things we happen to do, by the way, is we serve banks in commercial lending operations. And one of the things you have to do if you're a bank that lends to, let's say, 5,000 companies is you have to assess the risk in the portfolio. And the way you traditionally do that is you bring in financial statements from those 5,000 different people you provided money to, and you assess the financial health, and then you aggregate it up. Used to be done with CPAs and financial professionals. Now it's done using AI technologies. Now the AI technology is actually reading the PDF of a balance sheet. But it isn't just about taking the numbers out and extracting that. It's about actually reading the footnotes and converting those verbal statements into mathematical scores. So that requires a significant amount of understanding of the domain and tuning the extraction engines to be able to do those conversions on the fly and then be able to bring it in. And so in the real world, that data extraction, data engineering, data normalization is actually a lot of effort. And I would say it's 80% of the work associated with doing an AI projects. And I think it's important to plan for that going in early. I think on the flip side, the other point you raised, which is essentially adoption. Trust we talked about. And I think the advantage here has been, I won't focus on this, but the advantage here is that iterative nature, because you run through it in 45 minutes, you do the simulations, and over time you come to trust. In the business world, it's sometimes difficult to go through those thousands of cycles to get to the point that you instinctively trust what's been shown. And one of the ways we've gotten around that problem of not having that history to develop the trust is in the way we design AI, in the way we implement an AI engine now, we put breadcrumbs in place. So AI is fundamentally a black box business, right? I mean, it is, computer vision is literally a black box science. But what we do is we put breadcrumbs. So, in that financial risk assessment model, we'll present a number. And you might say, well, actually, that number doesn't look right. So we'll click on it. You click on it, it'll break into the 100 numbers below that. You click on the 7th one, because that looked too high. It'll break into the next set, right? And you click to the one balance sheet, which was actually skewing everything else that led you down this process. And you click on that, it'll actually show you the 2 sentences it picked from the introduction letter that gave you that risk sense. And you can still say, Sanjay, I don't get that, right? How did you convert those 2 sentences into that score? And I'd kind of go, well, how would you do it before that? You'd go down and talk to Bob over there in the aisle, and he would tell you the same thing. But the aspect of putting the breadcrumbs in place gave you this traceability to that small kernel of information that drove that big result. And that drives the sense of trust and I think that's been a big learning for us. So
this is the explainability.
This addresses the explainability. And so it's been a big learning for us, which is it isn't about AI, it's about how AI is implemented in the enterprise that drives the explainability.
Question over here.
Yeah, Sylvain, you made a very interesting point around the concept of the burden of legacy. You didn't have to deal with that. If you found yourself sitting in the seat of somebody who is dealing with the burden of legacy, any insights you might share? Because I think there's probably a lot of folks sitting in the seats out here that are dealing with that burden of legacy and building teams or building new capabilities. Maybe just insights the panel could share on how you would deal with it if you found yourself in that seat.
Sure, yeah, it's a very important point. And again, I'm fully aware that in my environment, it's easier than the smaller you are, the better it is, but it's about change, right? And then I've seen knowing very well the other teams in the championship as well as people in Formula One. Formula One are in that situation. Because they have bigger teams, they've been doing things the same way for a long time, and are realizing there are now better ways of doing it. but they have teams of 500 to 1,000 people used to do it. So some, and you can see it, some teams are much better at embracing change. It's painful, but they know they have to do it. And some others just won't, and you can start to see the problem. So in Formula E, we are competing now. We are an independent team, even though we work very closely with Audi. And we keep on beating on the track all the time some very large manufacturers, works team with 3 times the people, higher budget, and so on. And they're getting really annoyed by it. And one of the main reasons is just that, because, you know, there's one particular team, I won't give the name, but they have they are employing a Formula One team to run their operations in Formula E. And it's not necessarily the right way to go, because these Formula One guys are doing it the way they always have, and it's not working in Formula E. Just different, it's a different sport. So, and then talking to, we speak to a lot of car manufacturers all the time, which are very close to Formula E, of course. And car manufacturers, or large OEMs, have also this challenge, which is that their industry and their business model is going to change fundamentally. They know they are going to have to go electric more and more quickly, but that will have huge ramifications. You know, like the business model making a lot of money on after sales, on the aftermarket will no longer be there. So where do you build the margin? That means you're talking thousands of people in one department. It's huge changes. So yeah, and then you see agile companies that can suddenly disrupt the entire industry. So everything I'm saying is nothing new, but what we are saying more and more is that it's true, it's happening. Like
sometimes that legacy baggage holds these,
even if you're a large company, you cannot ignore these movements because they are happening, and it's happening across all industries. So you just have to be brave and find a way to do it. But I've had discussion before, and in some cases, the one that no one can answer, and I certainly cannot answer, is around governance, right? Like some companies, the management team gets it, the CEO gets it, but because of the shareholding, the way it's structured, you know, if your targets are your share price over the next 3-5 years, sometimes you just can't do it. The changes you'd like to make will either cost a lot of investment in the short term, which will impact you negatively, or it's complex, right? So, yeah.
I would say, Ross, that there's a burden of legacy, and one of the things to think about is how to convert the burden of legacy into an opportunity of legacy, because the amount of the book of business that exists for large corporations that have been around for a while, and on the back of the data, perhaps dark, that sits there, and the ability to assess that. I mean, you know, part of what we do is we spend a lot of time in the Valley with kind of the venture community looking at startups and so forth in the AI space, and there's so many of these companies that are coming around saying, if only I had the data, right? If only I could get started. And so I think one of the things to focus on there is how do you turn that burden of legacy into the opportunity of legacy?
So in a couple minutes, we're going to go downstairs. You know, we've talked a lot about simulations. There is a simulator downstairs. It's not obviously at the level of the simulator that you use to train, but, you know, you use the simulator downstairs. Talk a little about what that experience is, what people could expect, and, you know, sort of how certain things are similar to how you think about, you know, using the simulator for training.
How I use the simulator for training?
Well, just compared to, like, you know, what should these people expect when they go and sit in that? You know, I mean, obviously it's very different, but, you know, there's a steering wheel, there's a lot of inputs, there's a screen. Just, you know, what could people expect from, you know, the experience that they'll get downstairs?
Obviously, our point of view, there's, as we said many times before, there's a lot of things going on. Silva said also that, you know, on the steering wheel we have a lot of information. We have multi-pages, 3-4 multi-pages we can swap to. Meanwhile, we are driving the car between concrete walls. So it's not like, you know, with all the other racing, like Formula One has, you have a lot of run-off areas, and in Formula E, you have none. So one mistake, it could be end of the race, and for me personally, that's how it's supposed to be. Yeah, in the simulator downstairs, you probably have some wall hits, so you can see how it is. But it's
Yeah, but even every little, I was watching, you know, every little, you know, decision that you have to make has huge impact, right, on sort of that. So in a couple minutes, we are going to go downstairs. Explore the simulator. There's some cocktails. We'll get to talk a little more. I know there is someone to talk a little about the actual experience here in the gallery. And, you know, this amazing, I don't know if you guys got to peruse some of the artwork and all that. But the last thing I want to end on, because we talked about changing this narrative about this human, you know, sort of machine interface and interaction. When we talk about skills, right, what are the skills needed in the future to really embrace AI and technology? You know, you talk about your engineers. You know, what do you see as the human skills that are needed to really sort of maximize the use of technology in the enterprise and racing? So, you know, what are the backgrounds of some of those engineers that were sitting there? Are they all just data scientists? You know, and what made them relevant to sort of, you know, that? And I want to talk about those human skills also in the enterprise. So, let's start with you. What are those key skill sets that you're looking for outside of purely the technical?
Yeah. It's one of the key challenges for me because, as I said, I'm restricted to only 20 people I can take to the track. I have more back at Silverstone at the factory, but still a relatively small team. And I need a combination of the core skills of motorsports, on how to make a race car go faster from a setup perspective, and then all the other software things we talked about. So I need to find all these skills, but I can't have just data scientists because they would have no idea what motorsport is like, and vice versa, right? So there's an element for me, the way I do it. I try to hire the best possible I can, and sometimes it takes years, it takes a long time for all my head of departments jobs. And then it's all about the cross-pollination and the learning from each department to another. Again, much easier for a team my size than it is for a large corporation, but that's still the way to do it. And then it comes from the top, right? I mean, I guess I'm a slightly unusual profile in motorsport in a way that I really understand motorsport and I really understand technology. And I'm probably a fair bit younger than a lot of guys who do that job in other teams. And other teams, some of the teams are led by guys who've been in motorsport for 40 years when I was just about born. And so they have more experience than me. But there are a lot of things that they have been doing for a long time that's just not applicable to what we do. So pros and cons on each side, right?
And the communication skills, right? The human skills of those people being able to communicate and prioritize the data.
At some of my software engineers, they are like 25, 28, 30 in my team, and they are radically different to what you would have, the kind of guys you would have found in a race team 20 years ago. So you have to know how to speak to them, what motivates them, why are they here? Some of my guys, they said they could work in a bank and probably make a bit more money, but they love the excitement of, they can code stuff, and then they go to a race 3 days later, and we win because of that. And they are addicted to this, right? So I obviously take advantage of that.
Right. So Sanjay, talk about, we'll end on what are those human skills, that you're seeing?
I think I use one word, and it picks up a little bit of what you said, bilingual. I think bilinguality is a really important attribute in the enterprise, in that what we're looking for is we're not necessarily looking for AI scientists. We look for supply chain subject matter experts that understand enough of machine learning. We look for order management professionals that understand enough of how to apply AI. We look for financial scribes, subject matter workers that understand how to apply NLP, natural language processing, right? So this ability to actually be bilingual is actually one of the key skills that's required in this new world of AI that we're getting to. And I think to the other part of your question, how do you get there? I think more and more companies are starting to think or need to start thinking of themselves as a learning company as opposed to the we know it company, right? Because you have to have that curiosity. You have to have that desire to learn and be agile and adapt that gets you to this bilinguality. Because even if you knew the two languages that I want my children to be bilingual in, I know by the time that they're adults, those are going to be obsolete. And so what's really important is this curiosity and this desire to learn.
Right. Great. Well, let's get a round of applause for Sanjay, Sylvain, and Robin.